Let's talk about something that is incredibly frustrating for AI application builders. You build this amazing agent, right? It crushes every single test you throw at it. But the second you push it into the real world, it all starts to fall apart. This quiet, creeping failure actually has a name. And today we are going to break down exactly what it is and, more importantly, how you can fight back. So, you know the feeling. You spend months, maybe longer, getting your AI agent just right. Your evaluation metrics all green. Accuracy is through the roof. Everyone is high fiving. You are ready to launch. On paper, it is absolutely perfect. But then, few weeks, maybe a couple of months go by, and suddenly you start getting user complaints. Failure rates are ticking up. And the worst part, nobody can figure out what's actually broken. I mean, the code is the same, the model hasn't changed. So, what on earth is going on? This silent, super frustrating problem has a name: agent drift. And it's not your classic model drift that you might have heard of. This is something way more complex, and it's hiding deep inside the architecture of your AI agent. So let's get into why we call this a silent failure. Agent drift is no sneaky because it's not like a big loud server crash. When you look at it, every single part of your agent might seem like it's working just fine. And that's exactly what makes it so maddening to debug. Okay, so here is the textbook definition. Agent drift is what happens when your agent's performance out in the wild just gets worse and worse over time. But it's not because of some single obvious bug. It's a systemic problem caused by the subtle little shifts in one of four key areas: what the user wants, the information the agent gets, its own internal thinking, or how it works with other tools. So that's the big question, right? If it's not one big bug we can just squash, what are the specific weak points we should be looking for? To really get it, we need to break this whole problem down into its core components. The best way to think about agent drift is to imagine it has four distinct culprits. Once you can figure out which one or maybe which combination of them is causing trouble, you can stop debugging the symptoms and start fixing the actual root cause. And here they are. First, you've got goal drift. That's when your users just start asking for different things than you expected. Then there is context drift. That's when the information your agent relies on gets stale or just plain wrong. Third is the reasoning drift, where the agent's own decision making process starts to break down. And finally, collaboration drift, which is when the external tools and the APIs it needs to do its job suddenly change or break. All right, let's start with the first two because they are all about the information coming into the agent. That's goal and context drift. These are usually the first signs of trouble, and honestly, they can be the toughest to catch if you are not looking for them specifically. Goal drift is really all about mismatched expectations. You trained and tested your agent on a very specific mix of tasks. But you know, in the real world, users do what they want. Let's make this real with an example of an order management agent. Okay, just look at this table for a second. During the evaluation phase, see how the tasks were perfectly balanced. And that gave us a great overall accuracy of over 90%. Awesome, right? But now look at month one in production. All of a sudden, more than half the requests are for update order. And that just happens to be the one task the agent is worst at. That single shift in user behavior tanked the overall accuracy all the way down to about 82%. And this chart just makes it crystal clear. Our perfect balanced evaluation world on the left looks nothing like the real world on the right. In production, one specific lower performing task started to completely take over. The agent skills didn't get worse, but the job it was being asked to do changed completely. And this is the absolute key takeaway here. You can have a perfectly fine model, but if your users start interacting with it in ways you just didn't see coming, your agent's performance is going to suffer. That right there is the very heart of the goal drift. So let's talk about the second input problem, context drift. Now, agents need good, clean information to make good decisions, right? They pull this stuff from knowledge bases, databases, even from the old chat logs. But what happens when that well of information gets poisoned? You end up with this simple but totally devastating formula. The agent can have a perfect, flawless reasoning process. But if you feed it junk context, like outdated product documents or irrelevant conversation history, it's still going to spit out a junk answer. And this is how a perfectly smart agent can be made to look incredibly dumb just because of its environment. Okay, so we have covered the inputs. Now let's shift our focus and look inside the agent itself, that is, at its core operations. We are talking about its internal thinking and its external actions. This is where we run into reasoning drift and collaboration drift. Here is a quick side by side. Reasoning drift is all internal. It's about the agent's own logic going haywire. Collaboration drift, on the other hand, is external. It's about the tools and services that the agent depends on either breaking or changing without warning. So let's zoom into the reasoning drift. Imagine you have an agent that handles invoice approvals. It works great. But then one day, the finance department adds a new rule. Any invoice over $50,000 needs a special approval. If nobody updates the agent's core logic, it's just going to keep skipping that vital new step, causing huge problems down the line. And it's not just about business rules. This can also happen from model upgrades or even tiny, seemingly harmless prompt changes that cause unexpected side effects. And then there is collaboration drift. This is when the world outside the agent changes. For instance, a travel agent uses an API to get flight prices. Then one day, the API provider silently changes the data format it sends back. Because of that, your agent might completely misread the price or just fail to book the flight. It's not really the agent's fault, but it sure is the agent's problem. Okay, so we have identified the four main culprits. Now for the good news. Agent drift, as complex as it is totally manageable. It just means we have to shift from that old build it and forget it mindset to a new one of continuous monitoring and active management. The solution is this continuous loop. It all starts with step one, where you establish your baseline. That's your agent's known good performance from your initial testing. Then step two is to constantly measure all four types of drift while it's live in production. As soon as the metric crosses a line you have set, you jump to step 3 and investigate what's going on. Step 4 is where you fix it. You remediate the problem. And finally, and this is so important, step 5, you re-baseline. You run all your evaluations all over again to set a new known good state, and then the loop starts all over again. And honestly, this code just hits the nail on its head. If you aren't measuring these four types of drift, you will constantly be chasing ghosts. You will be trying to fix a bad output here and a weird response there without ever realizing the real problem is a fundamental shift in what your users want or a silent change in an API that your agent is relying on. So if you remember one thing, let it be this. Agent drift is going to happen. It's inevitable. It's simply what happens when a complex system meets a messy dynamic world. The failures themselves aren't the real issue. The real issue is not having a system in place to manage them. Proactive management isn't just a nice to have, it is absolutely critical for success. So, the real question isn't if your agent is going to drift, it's whether you will be ready to steer it back on course when it does. Thank you.